Okay, so we looked last time at what the architecture of an RPC implementation may be. And one reason to decompose an RPC system into components and specify what the components is to be able to replace the components. Okay, so today we'll see how we can replace those components. And the lecture is going to be less about RPC and more about software engineering, because we'll just see various ways in which we can replace a component. And the components we'll replace happen to be RPC components. Okay, so the RPC will be a driving example for this stuff. Okay, so again, we divided things into layers, and then we further had layers divided into producer-consumer pairs and receive trappers. And now let's talk of replacement. Okay, so I see a lot of heads down while looking at the laptops. Okay, you guys need to pay attention here. You're so used to not having lectures. So what is the replacement unit in an object-oriented language? What are we talking of replacing?
So you're substituting a different class with the same interface?
Okay, so we can't replace a method. Okay, that means editing the class. So that's a very involved replacement. So we want something that's relatively little work. Ideally, we don't have to change existing source code. Okay, that's the ideal. So people talk a lot about open source code, and they think that's a wonderful thing to have, and indeed it is. But if you have to go and change somebody's source code to customize it, there's something wrong with the source code. So ideally, you want to make as few changes as possible in what you're customizing. You should, and which means ideally it should be 0. Okay, so we want to change a class with another class, and okay, so one class to another class. And Sam, you said class implementing the same interface. So do I really have, if I'm going to replace class 1 with class 2, do I really have to have either of the classes implementing an interface? You can extend it. Okay, so what is the relationship between interfaces and classes then? I mean, if you want to replace. I'm replacing a class with another class. Okay, so I could extend it, but that's constraining a little bit, right? Because I can't just, what if I don't want certain behavior? What if what I've got is not a, inheritance, you have to have an is-a relationship. What if what I'm having doesn't have an is-a relationship with what I'm changing? Okay, it's doing a totally different implementation. In that case, do I need the two classes to implement the same interface? Yeah.
Yes, because other places that use this class need to know what it can do, or
so there are places that use the class, right? And we're going to have to replace this class with another class. So this is interesting, that when you replace your class with another class, you have to worry about the other places that were referenced in the class and what happens to them. So supposing I have an increment class that has increment and decrement operations, and then I have a my increment class, which is a custom increment class, and let's say it also has increment decrement operations, but the two classes don't implement the same interface. What would the replacement involve then? So they have the same headers, they just don't happen to have a common interface. Yeah.
So you still have to change the type of anywhere it's used.
So the variables that are typed using that class, they all have to be given a new name. Okay, we don't have to go and change the method calls, but we still have to go and give them all new names. Okay, that is the problem that interfaces solve. That is-a solves, right? Is-a can be done through inheritance. It can be done through interfaces, and inheritance is not usable in all cases. So we have interfaces as a more general idea. Okay, so again, when I teach 401, my students have to deal with my draconian rule of having all variables to program to the interface. That means variables should be declared using interfaces, and this motivates that. Okay? So we are doing this without changing any variable declaration, and so that's why interfaces are here. Okay? So in our RPC example, I have two interfaces, duplex client port and receive notifier, which I've got spelled wrong here. I'll try to correct it before I publish this. And we have a duplex client input port that is given to you by Gypsy. And in that example that sample code that I've given you, there is a custom duplex client input port that we want as an alternative implementation. In the example, I just subclass, okay, but I needn't have. And similarly, we've got a regular registrar and notifier and a custom notifier. Okay, and they both implement the same interface trivially in the sample code by being one being a subclass of the other. Okay, but the original class did implement an interface. Okay, so this way we can go from one to the other without changing the variable declarations. Okay, that's important. So here's your custom. This is making this real, and the custom doesn't do anything interesting beyond just tracing. Okay, so it just goes and says that whenever a send operation is invoked, we'll go and say print out the destination and say that this message is going to that destination. Okay, that's all it's doing, and then it says super.send. Okay, receive. So we can use inheritance or delegation to reuse code. Inheritance means making a subclass. Delegation means implementing a new class that has the same interface. And if you want to reuse the previous class, we have a link to it. Okay, so we talked about that last time, one of the times. And in general, delegation is more flexible. Okay, and a custom receive notifier does nothing else but tell us where the message came from. Okay, so it says source gave you this message, and again it calls super. Okay, so it doesn't do much in the customization code, but in your assignment you have to do something interesting. Okay. Okay. So when we go and replace a class with another class, there are two things involved. We have to make sure that the variables get assigned the right value and they get used correctly. So we have made sure that the variable typing doesn't have to change. That's great. But the variables had to be assigned something, and that assignment requires instantiation of the class we want. Right? So by typing variables using interfaces, we didn't have to change the variables typing. But how to change class instantiation? Okay, so we have to do something. If we don't do anything, there'll be no replacement. Okay, we just want to do things with as little effort, with as few constraints as possible. So how do we make it so we can go, of course, everywhere that a class is instantiated and change that instantiation? Okay, just as we could have gone to everywhere where a variable is declared and change its class, its type. But we try to do better than that. Okay, if there are n instantiations of a class, we try to change only one thing, perhaps. Okay, and what's something that you might have learned or seen that allows you to do that? Factory pattern. Okay, so the factory pattern, and I believe you guys who've taken KMP's class have seen the factory pattern in those classes. And Jacob, I think I didn't teach the factory pattern when you took the course, right? I might have. So, but you've seen it. You've seen it since then.
Yeah, I have seen it.
Okay. So here's one way that people implement the factory pattern. If you look at open source code, you see this a lot. I believe KMP does the same thing because I just hear his conversations from my office at times. And the idea is that you create in the class that is to be instantiated, you create a method, static method that says create your instance, okay? And the class itself has a private constructor, so you can't instantiate it directly, but it has a public static method that goes and creates that instance, okay? and we could have a create method in a duplex client input port and a create method in a duplex, a custom duplex client input port. So did you guys see this in Ketan's class? Okay. So that's what, when I look at open source software, that's how they implement the factory pattern typically. I don't like this scheme. Okay. So what do you think is wrong with this scheme, given our goal? Factories are used for many reasons. Okay. One of the purposes for which factories are used, this is a great idea. But the purpose for which I want factories, which is to change all occurrences of one class with another class, why is this not such a great idea? John?
Well, since there's static, you can't really do inheritance.
Okay, so one of the things is that whenever you use static, you can't do inheritance. So if I want to create my own factory method that uses, so a factory method is a method that creates an object. Okay? And so this create method is a factory method in this particular class. So if I want to go and inherit a factory method, I can't do it. Okay, so that's a great idea. That's a good reason. Now, other reasons? Yeah.
You still have to change the class that you need to call create on in every place that it's used, so that you're calling it.
Okay. So, yeah, what's going to happen here? That's very good, what you're saying. So supposing I were to replace this class with this class. Everywhere, people who wanted an instance of this class were saying a duplex client input port dot create. Right? Now I have to go and change everywhere a custom duplex client input port dot create. So what did I win? Nothing. But why was this good though? I mean, this is not a bad pattern. People use it. Yeah.
You could push the create up to the interface.
Okay, before we try to solve the problem, why this is, people use this, and why do they use it? I mean, yeah.
If you don't have, that factory method called everywhere, then it can simplify switching. So there is some, I guess, sorry, I can't get the word in my head. It does make things easier.
It makes things easier.
Some instances.
In some cases, it makes things easier. It makes things, yeah, Brennan?
In general, you can use factory design pattern to implement singletons and dynamic subclass modeling.
Sorry, what is the second thing you said? First, singletons. Let's figure out what that is. Singleton means that you should have only one instance of a class. This is a great way of ensuring that. The constructor is private. You cannot use it directly. And the static method will go and say, have I already instantiated it? If so, return that value. Else, create the first instance. Okay? So for that purpose, it's great. Now, what was the second thing you said? Dynamic?
Subclass binding is creating different instances of a class depending on something that's auxiliary to a parameter. Like if you had an interface called service and a class called online service and offline service, and you call the create service factory method, if there was a Boolean which was on, if you wanted online, and off if you wanted offline, then you could say if online, return new online service, else return offline service.
Okay, but that's the same. So what you're saying is that I have a class and a superclass, both of which can provide me with service. Okay, so I can have service, generic service, or I can have online service, which is a special case of that service. Is that what you're saying?
Service is an interface. You could either have online or offline. It's dynamic subclass binding.
So are online and offline two different interfaces?
No.
They're the same interface? They're two different implementations of the same class?
Yeah.
Sorry, same. So that's the same thing as this, right? Offline, online.
Yeah.
What's the difference? And now I have to go to every offline and go and say use online.create. Yeah.
He's saying that
Yeah.
it can adapt as you go. So if you're on a system, the way I learned what he's talking about is factories that create either a Windows button or a Mac version of the button. So based on what system you're on, that condition will trigger that factory instead of the other one.
Absolutely. So you've given, I've taken the example of duplex client input port and a custom input port. You give me an example of an online service and some other adjective you applied to it. You're giving me Windows versus Microsoft. By the way, have you ever seen that? Where did you learn that from?
It was in an interview study guide.
And have you ever seen an implementation that allows you to do that?
No.
There is none. I have wanted this feature but you know what? These guys create toolkits. They don't program to interfaces. Swing and AWT somewhat do, but even then, it's not as if JText field and text field implement the same interface. GWT and Swing certainly don't do. So I had to go and create my own interface to sort of combine them all together because I needed that substitution. So Object Editor can go from AWT to Swing to GWT to SWT because I created this layer. And that was my favorite example, change the toolkit. But these toolkit providers don't program to interfaces, unfortunately. Okay? So you guys haven't, you're telling me why the factory pattern is good. But this factory pattern is not helping us, except for singleton. Okay? Because I have to go to, the class. I mean, you're tying the create method to the class. Okay? So when I want another create method, I've got to go to another class. Unless in this class you go and change the code and say, okay, call this class's create method. You could do that. But that's not very elegant. That's not very nice. Okay? Because this class now knows about this class. Okay, the whole point is that this class knows only about itself and it instantiates this. And in fact, this class cannot instantiate this particular class because its constructor is private and these two classes may be in different packages. Okay? Okay. So we've got the problem now. Let's look at solutions. What's the solution to this? Okay, so Nick is saying put create in an interface, right? So put in create in the interface of this guy.
Yeah, that will actually work because your constructor is still private.
Okay, Sam.
You can wrap them in a class. It actually has like a get for it.
Okay, before we go to that, what about let's go and debate Nick's answer there. Put the create method in the interface. Okay, but that will be equivalent to this, right? You just made that an instance method, and now on what instance do I invoke that create method to create the instance? If I put it in the create method of this interface, that means I have to call the create method on an instance of this interface. But that's the whole point. I've got into a recursive problem. Okay, I need to create the instance. So that wasn't. It's quite a solution, but the right answer is that put create in some interface, perhaps not in this interface. Okay, and Sam, what's your solution to that?
You just wrap it in a class that you ask for a version of that interface, and then you can put whichever version that you want.
You put create. Say that again.
So you say like you'd have a get duplex client input port, and that would be a method in a different interface. So
Okay, so you have a different interface.
Yeah.
What? Okay, you have a different interface whose job is to create.
Just to create versions of any class for you, or versions of an interface for you, and you can select which.
So you have a separate interface, not this interface, some other object
Yeah.
that creates this object.
Yeah.
Okay, Jake.
What I was thinking is you could make an abstract class that's parameterized, and so have it be like instantiator of duplex client input port as the interface, and then the create method would create a new of whatever the parameter was.
So you're sort of saying the same thing that Sam is saying, right? They have a separate class to do it. Or do you have this class doing it?
So
You said abstract class. That confuses me because you can't instantiate an abstract class.
No, the abs.
Yeah, go ahead, Jacob. Finish.
I was thinking the other thing I was thinking before that was like a factory.
Okay, yeah, we're going to get into this recursive thing. So what would you call this class that instantiates this class, this interface?
Well, in your code, it's called a selector.
Not quite, yeah.
It's like you call it a duplex client import.
No, that's just specific. But what would you call a class that instantiates another class? A builder is a separate pattern.
Okay.
So this is called a factory class. So I have gone from a factory method in this static factory method here, okay, to a factory method in a special class, which can't be abstract. It has to be instantiated, and we'll call that a factory class. Okay? So it's not factory producing a factory. We haven't quite got to that stage right now. It's just a single level factory right now. Okay? So that's what we'll do. So this solution is instantiated class as private constructor, instantiated class as static create method. Create method takes instantiation parameters. Okay? So these parameters typically become constructor parameters. Okay? But you could have an if then else or something saying if the user has said this, then do this, and otherwise do this. Okay? And good solution for creating singletons. Okay? Absolutely great solution. Okay? And people sometimes just get confused and think that's, you know, they've got all the advantages of factory classes through that, but it's an awful idea for replacing a class. Okay? And I say that while feeling some pain, because I have gone and tried to deal with people's open source code and said, why did they do it this? Firstly, I said, why didn't they have a factory method? And then I said, oh, these guys have factory methods. Oh, why did you put it in this class? You know, so, and why did they do that? You know, it's always a pain to take those extra steps. So I don't blame them, okay, completely. But, you know, and they didn't know I was going to change it in a certain way. So getting rid of the replaced class gets rid of the static method. Okay, so if I'm getting rid of the class, then I have to use a new class, and we are not even thinking of that class. So there's no create method, and so we kind of saw that. So instantiation method should be outside the replaceable class. That is the model. Okay, and we'll have a factory class. And now we're not going to have a factory class instantiate only one kind of class. We've got a separate class, it might go and create a bunch of classes. Now, why might that be useful?
They can be related to each other.
Sorry?
They can be related to each other.
They could be related to each other. And have you seen an example today in which we wanted to change a bunch of related classes?
The examples where one class extends the
So that's changing one class to another class, right? Did we see an example where we want to change a bunch of related classes to another set of related classes? I'm looking at you.
Yeah, okay, I thought you were, but I wasn't sure. Yeah, I guess you could have a factory that creates maybe, let's say, a window or a calculator. I guess it could, I don't know,
No. What was the example you had given earlier?
a button,
Button.
Windows versus Mac.
Right. Don't I want to change the whole Windows look and feel to the Mac look and feel? That's what.
I'm sorry.
So Windows, if you're going to change the window button from window to Mac, you might want to change the text field button also from window to Mac.
Yeah, that's why I was starting to explain the window thing.
Oh, okay. Calculator.
The different.
Yeah, exactly. So you're taking a specific window, calculator, and saying that all the things you want to change. Okay. So in the system that virtual toolkit that I built that is used by Object Editor, you change the whole look and feel by using the appropriate factory. We make sure that these classes are consistent. Okay. So you might add, in our example, you might add a port that timestamps a message. Okay. Then you want to also have a corresponding receive notifier that removes the timestamp before it goes to the serializer. Okay. Or before it goes to the remote procedure call module, okay, which is going to invoke. So you send a serializable call, you timestamped it, then you remove the timestamp, and then forward the serializable call to the receive, to whoever processes it. So I want to have both of these things change together. If I use one port and one notifier that's not matched, my system will fail. Okay, so we can have multiple create methods. Okay. And again, you know, the methods in the factory, the create methods are very similar to what we saw in the previous case. Okay, we just moved them to a separate class. Okay. So changing changing instantiated classes meaning, okay, so I'm getting the disadvantages. So can you guys see it? Okay, so these methods, do they need to be static or instance methods? So let me propose static methods here for now. That these are all static methods. Actually, the point I want to make can be made with both. So, okay, so so now what I'm going to have for the input port factory, I'm going to have an input port case. I'm going to have an input port factory that has a create method that can create one thing or the other. Okay, and it can be static or instance. Let's punt on that a little bit right now. Okay, the factory is a singleton, so you can go either way. Okay, and in general, instance methods are good. Now, can you see a problem with this? So I change it. You know, my create method went and created one kind of input port, and now it creates another kind of input port. Yeah, Sam?
If the constructor is different, then you have to change out your create methods.
So you have to change all the create methods. If the constructor is different or the class name is different, you have to change the create methods. You've got to change something. So maybe we're happy at this point, but I'm not. I've got this pinkish color means, you know, or reddish color means now I'm not too happy about this. So what is this line saying? So I went and changed it. I changed it from the regular one to the custom one, right? Which could have had different constructor parameters perhaps. Okay. Remember though, these parameters are fixed though. Huh? If these parameters aren't fixed, then I can't have all the other code have a single create call and not change. So the create methods don't change, but yes, the factory could go and add some extra parameters, remove parameters, you know, it could do these things when instantiating. But now what's happened is that I've lost information about all the, how I created the previous class. So if I want to go back to it, so if you've ever seen me program, I never delete anything, I just comment things out. Okay? So you can always go and say, okay, I know what it was before, so you can go back to the previous comment, but previous code, but if that code's constructor has changed, your comment never got checked, so you know you might get into trouble that way. Any other disadvantage of this? Can you see where the previous solution was a little better than the solution in some respects? We see in this respect it was better. In that class you had information about how it was instantiated, and when you went to another factory class you didn't lose information about how the create method was done. So so information on how to return to the previous classes is lost and needs access, and also you need access to the source code. I have to have an open source code implementation so that I can go and change the factory there and have a separate create call in there. I can't just have a jar file there that can be used to change the factory. Okay. A factory class needs to know details about all the replaceable classes. Okay. Unlike the previous solution where each class was sort of bound, factory method was bound to the class, so I don't have to know about all the possible classes. I don't have to know all the constructor parameters I need to pass. Okay? And you will need a public constructor now, because you know this factory class needs access to all the other classes. Not all of them should be in the same package. So you need a public. So I can't do singletons now. Okay. So now it is spread out. Okay. And static methods are not overridable. So maybe we shouldn't have static methods. Maybe you should have instance methods and so what do you think is the solution here? Okay, let me, yeah, Jacob, were you thinking something?
I was thinking something sort of like the visitor pattern, where you would have all of the, like each of the class, like so the factory would call create, so like each interface that can be factoryized has a create method, and so when you call that create method, it would, I mean, it wouldn't solve all the problems, but it would allow you to continue to have like singletons and things like that.
Okay, no, let's get this right. So, I imply here this is a static method,
Right.
even though I don't write down here, by this comment here.
Right.
So you're saying we're not going to have a static method, we're going to have an instance method.
No, what I'm saying is like the create method in the factory would then call a create method in whatever class that you're instantiating.
Ah, so the factory somehow goes and calls that class's create method.
Right.
It'll solve some of the problems.
It will, but not all of them, yeah.
Excellent, excellent. I didn't think of this idea at all. Excellent. So some of these problems go, but I still need access to the source code. I still need to, and I don't have to worry about the public constructor business.
Right.
Beautiful, beautiful. That's great. But I still need this to go to this factory, and I still need to change the source code.
Mm-hmm.
Okay, and what have we done? We've added 2 levels of factories there, right?
Mm-hmm.
This is a factory method that calls a factory method.
Right.
So the answer is going to double level of factories, right?
Mm-hmm.
And what problem doesn't it solve, by the way? Does it? Changing instantiated classes means changing all the create methods. So this create method would have to change, right?
Well, if it like if it just called a create method, then you wouldn't have to. You would, because if all of
Because I'm going from I'm going from one class's create method to another class's create method. So I have to go and change this, and you have to make some changes.
right, yeah.
Okay, and so you'll make that change. Okay, and you've kind of lost information about the previous class, because you kind of, but not, because you probably know which class to go to, so you can just call that class's create method. So this problem solved. This problem is solved. Do you still need access to the source code? I need to go and change this create method. Okay. Sam?
You have a class that chooses your factory, so you can just write a separate factory without access to the source code, and then insert it and tell the program to pull from that factory instead of the one. But instead, you basically choose, and then it gives you the flexibility to choose at any time which factory you want to use.
Okay,
So you
Brennan?
can wait till runtime even.
Yeah,
or you can-
Brennan?
And to an extension on that, you can have something called like set factory, that way you won't have to have access to the source code.
Okay. So the 3 answers we've seen all involve double use of factories. Jacob's answer is, a factory method calls another factory method. Okay, so we keep that factory method around, but we don't have a factory class. And what your answer is saying is that no, don't have that class have that method. Have a separate factory class that goes and chooses between factories. So for each class, you still have so for each class that should be set of related classes to be changed, you have a single factory class. Okay, and that factory class instantiates that kind of factory, that kind of object, so you don't lose it. And then you have another class that chooses which factory to use. Is that's what you guys were saying, right? So you have a factory for factories.
Or a selector for factories, basically.
So that factory for factories, and anybody who's done software engineering, what's that kind of factory called? Jacob used an adjective that I didn't like very much in that class, in that particular context, but now we can use that adjective.
Abstract.
An abstract factory. It's not an abstract class,
Right, yeah.
but it's an abstract factory, and which is what I call a selector. And that's what you guys were talking about. But then if I keep going this way, you know, I have a factory that instantiates a class, and then I have an abstract factory that instantiates a factory. Then who instantiates the abstract factory? I mean, how do I end the recursion?
Wouldn't that be the set factory?
So the key is that the factory is a singleton. Factory doesn't have to be, you can just have a set in the abstract factory that says, here is an instance. Okay? And the abstract factory doesn't have to go and create multiple times an instance. So you can just have one singleton that is set and get, and then the problem is solved. Okay? So the fact that the factory is a singleton solves our infinite recursion problem. Okay? So that's what we'll have. So we're going to have a factory class with instance methods. Okay? We're not going to have static methods. And the various factories are going to implement this interface. Okay? And factory instantiates a set of related types such as ports, and different implementations can instantiate different classes. Okay, so you guys gave me the answer too quickly. I'm going to the answer very gently now. So I'm just saying, hey, we're going to have factories that instantiate. They're going to have instance methods. They're going to have interfaces, and different implementations of the factory can instantiate different classes that we're interested in. So factory class can now be tied to replace class, can be in the same package. Okay, and so we can do singletons now. Okay, and we refer to this as the factory class solution. Okay, factory is a very overloaded term, and this is a factory class solution. Okay, as opposed to a factory method in the instantiated class. Okay, and here's an example. We've got a duplex input port factory interface that tells you how to create the duplex client input port, the duplex server input port, which are tied to each other, takes parameters, and I can have a duplex input port factory and a custom duplex input port factory. So we have two different implementations of the same interface, and as we saw, the factory can instantiate multiple classes. And here's my factory. I just went and extended the previous factory because I'm being lazy, you know, and I don't want to duplicate some of the methods that are in that factory. And my create method here just calls my custom guy, and this create method calls my custom guy. Okay, so pretty much this is just seeing very concretely what the abstract ideas I just had. Okay, so we've got factories. We haven't solved the factory problem, recursive problem, but we solved the problem to one level. Okay, and this factory is instantiating classes. Okay, it's not doing getting and setting because these may or may not be. In this case, they're not singletons, so it's always creating a new instance. Okay. So choosing a factory, that's the problem that we want to solve now, and how to change factory choice. And key is the factory is a singleton. Okay, so we don't need another create method to create factories, and we can have, for instance, a static global registry, which has these properties. That means it has a set and get, which is what Brennan was talking about. Okay, so I can set the simplex buffer input port factory. I can set the duplex buffer input port factory, and so forth. And anybody who wants to instantiate the appropriate classes does a get on this selector registry, and after doing a get, calls the create method in it. Okay, so everywhere an instance is needed, you do a get on this. You do a get factory, and then you ask the factory to then instantiate. Okay, so your instantiations become a little complicated, but all you have to do now is in your code, in your main method, you can just use Gypsy as a jar. In your main method, you go and say selector dot set factory to my factory, no source code needed, and all the gets will return your factory, and then return your class as a result. Okay. So this is a solution I first had, and I didn't like it, and I changed it. And it's not quite what you guys have seen in your assignment. I'm saying there's only one abstract factory in the whole system. Can you guys see the problem with that? Jacob, what's the problem?
If you have like, so one problem would be like if you have like multiple things, like if you have multiple, like not just input and duplex ports, but also say have one that you want for like buttons or something, then you'd have to store all of them. That would, and so you'd have to edit it just seems that there would be a lot of confusion there.
Separation of concerns is not there.
Right, yeah.
You know, and that was a real problem. I never knew which package to put it in. Every package was doing something, and this was what? You know, I could never, you know, and it was a mess. It had so many different variables, and it just violated. But you know, it was the lazy thing to do, and we all tend to do the lazy thing till we sort of get burnt. So this is not a solution quite what you saw. What solution did you guys see? Or what is the right solution to this? Yeah.
You created a selector which just branches for basically a particular factory set.
Yeah. So now you say a bunch of related factories get chosen by a selector. Typically, each factory interface has a selector. Okay? That's and has a link to all factory instances, static methods change and get references, must change registry each time a new port is added. You know, each new kind of port is added. Okay, that was the problem I was having. I had buffer ports, then I had object ports, then RPC ports and session ports, and every time I had to go and deal with this thing. Okay, so we have a factory selector and helps choose between among factories. Okay, and it has a set get factory, set factory, doesn't have to do a create. Okay, and the create methods here are just convenience functions. They go and have the same signature as the create method in the factory. In the factory, the create method is an instance method. In here, the create method is a static method. The create method here chooses the factory and then calls the instance method on that factory. Okay, so I don't have to go and say selector.getFactory.create. I can just say selector.create. Okay, in my code. So that's just a convenience there. Okay. So the factory selector has a reference to a factory. Doesn't create references, doesn't create objects, but has a reference. Okay. So, so static method to change and get reference to the factory, and can get reference to factory and invoke factory method. So that's the create method. So abstract factory provides static versions of factory creation methods for convenience. Okay. Any questions before I leave this? Okay, so here's my selector. It has got a set duplex input port factory, and it's also got a create a duplex client input port. Okay, so it's exactly what I was talking about. Yeah, I don't know why I've got two create methods here. I guess I was trying to show that there's both a server and a client create method. Do these guys take different arguments? Yeah, so it seems like I duplicated this method. Okay, so I'll delete. I'll try to remember to delete this from the published version. Okay. So remember, I choose the duplex input port factory, and the duplex input port factory creates both the server and the client. So that's right. The duplex guy creates has two creates in it, and those are the two creates I'm supposed to have here. And I think I just made a mistake here. This should be one of them should be a create server port. Okay, because this factory interface has two create methods. Okay, so that's the confusion here. Okay, questions? And I've got it right here. Okay, so I've got a create duplex server input port, create duplex client input port, and I just say input port factory dot create, and I have a get and set for the input factory. Okay, nothing surprising at this point. And now if I want to go and change it in my main method, I go and just set the appropriate factory in the selector without having to change any source code. Okay? So I've kept for myself here, you know, that's in case I want to change back. I've got the old code lying here, but and we'll talk about there's two versions of call invokers. Actually, I've got the same version here right now, huh? But there's actually two call invokers that I'll change between. I'll tell you why we change between them. Okay, so we've addressed the problem. Now, you know, I can tell you that you're being bad if you don't use a factory and abstract factory. But in life, we take shortcuts. So just as, you know, they'll tell you the perfect recipe to cook your favorite meal, and there'll be shortcut recipes, and which is better than going out and eating junk food. Okay, so let's go, and we know now that having typing things using classes and is junk food. Okay, we want to do better than that, and directly instantiating classes is junk food, but we don't want to go to this very involved recipe necessarily. Okay, so a lighter weight choice. Have you guys heard the term? I've told you the term factory class. Have you guys heard of the term factory method? I kind of used this term when I talked about the static method in that class. But have you guys seen the notion of an instance factory method? You might have even. Jacob?
Sort of like a clone or something, maybe? So like it would create an object that has the same members, and so like it would copy over the members from the previous.
Excellent. Clone is an example of an instantiator. That's an instance method. But clone is a very special kind of instantiator. It instantiates itself.
Right.
What about an instance method that chooses between multiple classes? Have you guys seen this concept anywhere?
Like, I don't know, the one I can think of was the Gypsy registry lookup that takes the class of the remote object and returns that object.
Oh, so the Gypsy lookup or the RMI lookup.
Yeah, but the Gypsy one takes the dot class. Right?
Oh, okay. Okay, that's good too. That's good too. So again, we are creating an instance, and it's not quite instantiating the class.
It's a lookup, so, yeah.
You know, it creates a proxy. It creates a proxy if necessary, but it's not that class. It's some version of that class. It's like a clone. Actually, that's excellent. That clone method and that lookup method are very related to each other. In one case, you're creating an exact copy. In the other case, you're creating a proxy to an existing copy somewhere else. Brennan, assignment 4. Did you see an instance method that creates a class? That creates an instance of a class?
Would that be the custom notifier?
Ah, yes, good. Okay. So what you do is you create a method in a class. So you have class C that needs class D. Okay. So class C is instantiating class D. We won't have class C instantiate class D directly. That's junk food. We won't have class C use a special factory class for class D. That's, a 5-hour recipe. What we'll do is put a method in class D, class C, that creates class D. Okay, so everywhere that class D is needed, we'll call that method. We might need it more than once. And now when I create a subclass of class C, and if all I need to do is change which version of D is to be used, I change that factory method. I override that factory method, and I get a new kind of instance, rather than the instance that class C chose. Okay, that's the idea. So I'm saying, whenever you have to instantiate a class in some class, don't instantiate directly. Please create a method to instantiate it. Later, you can go and have that method call a factory class, a method in a factory class, when you've got time and you really know you have the need for it. But for now, just do that. so that if somebody subclasses your class C, they can change which instance is being created. Okay? Lightweight choice. Not quite the pure thing, but better than doing it. Okay? So my custom duplex object server input port, it needs a receive notifier. Okay? And it calls a method called create receive registrar and notifier that normally just goes and invokes the gypsy notifier. If you go and subclass the server port to your class, okay, you can go and change that notifier by changing this method and not changing anything else. You don't even know how this object is being used. You just know you want to change this object. Okay? My last 401 final and midterm kind of used this a lot, and they saw a lot of simple examples where this would be useful, and this is a very useful thing. Now I say that with some guilt, because today, there's only two kinds of people you'll encounter. One are the purists, who typically don't implement things, so they like to preach, and one are the people who like to do things, and they often don't listen to the purists because it's too much pain. So the purists will say, don't teach factory methods. They are not as good. Why is this solution not as good as a separate factory class?
We have to create an entirely new class just to change the factory method to change which is created instead of just calling set factory on existing.
So you're saying you have to create a subclass to instantiate this, right?
Yeah.
But I had to, even in the other example, I had to create a separate factory class to instantiate. For each object that I have to instantiate, I had to create a new class there. So whenever I create a new version of some interface D, I had to create a new class there. Now to create a new class here too. So it's no more work.
Yeah, I was thinking specifically in the case where, if the only thing you need to change is what happens on receive. You can't just say, just use this receive instead of the default one.
I didn't plug it in, huh? I better not lose this recording because, okay. And it's good that I got it to 30% and not 5% because we would have been lost by now. Okay, sorry, say that again, I got distracted.
Yeah, so if you only needed to change the receive notifier, if you wanted to do that using this setup, you have to create this class basically here, as opposed to just saying in some factory, like you did with the input port loading, where you can just say use this input port factory.
Yeah, so if that factory already exists,
Yeah.
it's used once. Whereas every class that needs to subclass this, wherever this has to be changed, all the subclasses have to go and do this new. Whereas there, you could just call that one method,
Yeah, exactly.
if that factory already existed. Good. So in that sense, it is more work, right? Especially if you have to do it multiple times. And kind of related to that this method cannot be called from arbitrary classes. Every time you need to go and change the thing, you have to create a subclass to do it. So this method is not just accessible from everywhere, and it's not shareable, which is kind of what John was saying. Okay, it needn't even be it's a protected method. In fact, it needn't even be a public method. Okay, so if it's a public method, you're going to create an instance of this class to go and call this method. So work gets more. If you have to do this overriding of this particular class at multiple places. In each of these places, you've got to do a subclass. Okay? The nice thing here is that all subclasses of class C that needed to use this can use, its subclass can, in a hierarchy, it gets shared. But when you have different hierarchies, there's no sharing. Okay? So, but it is lightweight. Okay? So you don't have to create a new class. So if you're going to do it only once in one place, it's convenient. Okay? And if you use this approach, the factory class approach is still a choice, okay? Because you can just go and change this method to call that factory method. Okay, so I recommend that whenever you instantiate something, just do it in a factory method, and later you can create a factory class. So variable factory methods frowned upon, but better than no factories. Okay, we have 15 minutes left. We've understood the software engineering aspects. Now let's go and figure out what this example is doing and what kind of components is changing so that we understand the architecture a little better. And so you guys see here that, I've got two kinds of received call invokers. I've got an asynchronous version and something else. So I'll talk about the asynchronous version later. So that's why this comment exists. So Brennan probably knows how to answer this the best because he's done the assignment. Anybody other than Brennan want to tell me what the received call invoker is doing?
Like the server, whenever you get a call, it's how it handles what it's in fact.
Okay, so it is the server. Yeah, I forgot you also done the assignment, so there was a little cheating there too. And Brennan says, why didn't I get to go and add to my class participation? So this is the, and of course you're going to forget to do it within the time, right? So there is some component in the server, in the caller end, that goes and invokes the actual call, right? We are not making a call directly in the server. So some component has to call it. That component is the call invoker. Okay. Okay. Somebody other than Sam and Brennan. What is the call completer? John says, I know what's going on there too. So John, what's the call completer? No, Brennan, let's give you a chance. We haven't spoken enough today.
Okay, the call completer, is that the one which handles the returns from the function or procedure?
Yeah. So at the client end, you first send the call, then you have to complete the call. So the call completer, in case of a function, executes after the call invoker in the server. So the call completer is the one that decides whether to wait for the server message or not. In the case of a procedure, it doesn't wait. And in the case of a function, it waits for that. Okay? So we know what object input port is, and we talk about the serializer. So here's the caller pipe. And you guys have another set of slides that talk about the basic algorithm. But what's going on here is that the caller is an RPC port. Okay, it gets a call method invoked, and it sends it through the call sender to the object port sender. Okay, so from the RPC port, the message goes to the object port. Okay, and and this one, I made all these slides this morning, and I made a bunch of slides, so let's go and see. So now when the message comes in from the server, it goes through the call completer if it is a function. And that goes and returns the message. So that's what's returned. So that's what the call completer is. The call completer for the function is on the way back from the server, message that's coming back from the server. Okay? So that's the caller pipe. And this particular call sender also invokes part of the call completer. In case of a procedure, the call completer just returns immediately. And in case of a function, the call completer waits for the message back. Okay? So that's something that's involved in both the pipes. Okay? And so what's happening here is that the received message comes in, it goes to the call trapper. Call trapper says, that's a return value. So the call trapper goes to the call completer, which is a shared data structure between the call sender and the call trapper, receive call trapper. Okay, so this is a shared data structure. So this guy goes and calls the call completer, and the messages go up. And the call sender, in case of a function, goes and enqueues messages that is accessible to the call completer. So there's a shared data structure here. Okay, so that's the caller pipe. This is a callee pipe. So a message comes in to the callee. The callee goes and figures out, oh, it's a call. Okay? So let me invoke the call. It invokes the call, doesn't send a message across to the other parts of the pipe because that's a call. That's not a regular message. You don't have to worry about, don't have to send it to the receive listeners that are listening to the message on the object port. Okay, so it just short circuits, doesn't send anything forward, and calls the method. And what is the arrow saying here? So it makes a call, okay, at the receive and the server. And what is this arrow you think saying? If it's a function, send the return value back through the send chain. Okay, so this algorithm is discussed more in depth in a separate PowerPoint. I'm just trying to remind you guys how this fits in with the architecture we have. Okay, that PowerPoint is basically on the algorithm, not on the architecture. So that's what's going on. Basically, what we said earlier, I'm saying with using more pictures. Okay, so the call invoker is invoked on the server end, and the call completer is invoked at the client end, and it gets a value sent back from the server. Okay, and you see here that these trappers don't always go and send whatever they've got, some version of it up the layer. This guy will not send the serializable call to the object port. Okay, receive listener. Okay, so that's what's going on here. This didn't go through there. Whereas when the serializable call was generated, it did go and send it through the object sender as an object, okay, which it sent back. But up the chain, it doesn't go. So here's my custom call invoker. It does nothing else but go and override a bunch of functions that are important from your point of view. So this is the one that decides what to do with the function return, whether to wait or not to wait. This is the function that decides what to do with the function return. So this is the method that decides what to do with the procedure return. This is the method that decides what to do with the function return. And this is the method that actually waits for a function return. And this is the function that is called, this is the method that's called when a new message is received from the server saying, hey, there's a new value. Okay, so there's a bunch of functions that have to be called, that are called, some from the sender pipe, some from the receiver pipe. So these methods I describe in the assignments. You've got a good idea of what they mean, at least from the point of view of the assignment, which ones you have to override. Okay, but this is the producer. This is the one that receives the return value, and this is the consumer. It waits for the return value. Okay. In the call completer. Okay, and right now these things are going through a queue, and you have to go and use receives to implement this. Okay, and this is the part that's easy. So Brennan, did you get this implemented?
Yeah.
Okay, this was easy, right? I just want to point out one thing, that in the PowerPoint that I created the last time I taught this course to the grad students, I use different names from the names I have now, just because these names make more sense to me than they make to me. So rather than I've got the word get now, rather than just return value of remote function call. So you know how if you have an int value, you can say counter left parent right parent, or you can say get counter. Okay, and they both make sense, but I feel counter without the get shouldn't have any side effects, shouldn't be blocking you, shouldn't have anything surprising there. And so I put the words get here because these things can wait and it can have side effects. So that's why I've changed the names. Okay, and these are the old names. So just in case you guys get confused. And what I've done is, just to be compatible, I've implemented the old methods using the new names. So just in case you're looking for the old names, you'll find them, and they'll do the same thing. Okay. Okay, we're about to end. So serializer, you guys remember what the serializer does? You've got it's something that's involved between the object port and the buffer port. okay? And when data are sent on the object port, they have to get serialized to the buffer. And when data are received from on the buffer port, they have to be deserialized to the higher level port. Okay, so that's serializer and deserializer. And what we're going to do, we're going to just go and trace it. Okay, so we know that in the serializer, we're going from a buffer to a object. So I go and put this printout saying buffer to this object. And in case of deserializer, I'm going from object to buffer. So I put this method in. And both the serializing method and deserializing method are in the same class. Does that make sense? Am I not following separation of concerns by putting the serializer method and deserializer method in the same class?
Say serialization is a concern. So you just have a class that handles serialization either to or from, and they probably need to share a lot of similar methods to kind of code and decode the message.
So how you encode determines how you decode, right? So it's probably a good idea to put them in the same class. Okay. You could put them in different classes and have factory classes choose them. Okay, so there's all these choices to make. But I just, and this is how it's done in Java also, RMI also, serialization also. So they put it in the same class. I put the same class. Okay, so just so that we understand what's going on, this lecture serves two purposes. One, it motivates factories. Okay, that was the easy part, or the non-messy part, and then it also describes how the RPC implementation works. And so let's go and focus on the RPC implementation. So let's look at this sample code. You send byte buffers, then you send one byte buffer actually. You send an object, and then you invoke in the increment operation. So on the client side, given the tracing I've done, what would you expect in the output? From what, if you can remember. So send byte buffer, okay? Now we went and put tracing for the call completer, call invoker, the serializer, the deserializer, for a message being sent on an object port, for a message being received on an object port. Okay, those are the actions we are actually tracing. When I send a byte buffer, will any of this tracing code be executed? Will the call invoker be executed? No. Call completer? No. Serializer? Buffer is already serialized. What about send message on an object port? Probably.
Depends on what layer. You have general. If everything goes to a byte buffer, eventually it gets sent, and that's how it works. Yeah.
But I trace the send in the object port, not the send in the buffer port.
Then probably you just call send to the buffer port.
Yeah. So what's interesting is this, that it will get traced. Why? I call a send on the RPC port. Okay. The RPC port says, okay, now the RPC port has a send object. It cannot also have a send buffer. Okay, you cannot, if you look, it's a generic type. You can't have two methods implement the same, two different implementations of the same generic interface method. So I have to call the send object method, and the send object method, so that will get traced. As it turns out, the send object method says, if I've got a byte buffer, I won't make it go through the serializer. Let's not waste the serializer time. So the send object method has got an if statement saying, if object is byte buffer, don't serialize, send it directly to the lower level buffer port, otherwise serialize. Okay? Now what about when the byte buffer comes back? Will the deserializer be invoked or not? So the serializer never got invoked. So why would the deserializer get invoked? Your answer is right actually, but why?
Everything comes in as a byte buffer, and it doesn't know that what you sent on the other end was just a byte buffer. It could be a message.
That's it. Everything is a byte buffer. It doesn't know whether that byte buffer is something you send directly or it's a serialized thing. So it tries to serialize it using its encoding philosophy. It finds that its encoding is not being followed there. It says, oh, it's corrupt. It's a corrupt byte buffer. Let me just give it to the higher level layer because they probably need the byte buffer. Okay? So this is what you get from a multi-layered scheme, methods, port, where you allow to send byte buffers and objects.
What if your byte buffer just happens to be?
If it just happens to be, you convert that into an object. The chances are very small. You can put some magic characters, magic things in there to make sure that it's not, okay? But you have to have the size field there. It's just, the chances are, somebody will have to know the encoding scheme to make that work. Yeah, but yes, you're right. It's not foolproof. Okay? So here's the output. And you guys can look at it and ask me questions later if you have issues. But you see here that this message went through the client object port, and it said, I'm sending to the default server this particular object. Okay? And then, but it didn't get serialized. Then it said, I'm sending 2 to the default server. This is in the custom object port, I got this message. And then this one, the serializer got involved in and said, I've converted 2 into this particular byte buffer. Okay? And then the call got made. So the serializable call got made, and default server says, okay, I'm sending, the object port says that I got from the higher level port a serializable call. That's just a data structure as far as I'm concerned. I'm sending that to the default server. The serializer said, oh, I got an object. I don't know it's serializable, it's a serializable call or not, but it's an object. I'll convert that into a buffer. And then, at some point, the get return value of remote procedure call got called. That's in the call completer. And it said, oh, I've done the send. Now, do I have to wait or not? So it went and said, okay, I will not wait. And it just returns null. And then it said, look from the default server. Hang on. So then I'm sending the get value call to the default server. So that's this particular object. And again, we go through the same process that we went through the increment. But this time, the function call blocks, and it says, okay, I got 6 from the default server. Okay, and I'm returning 6, and that 6 was processed. Okay, so you see the messages going forth and back and forth here. So this one says, I'm just sending the byte buffer to the object, default server. I'm sending now a 2 to the default. Okay, and then we start incrementing it, and when we increment it, we have got to, when we call methods, this is a much more involved process.
So like when you do send buffer, nothing gets output.
When I send buffer, something did get output, but the serialization part, the serializer didn't get output.
I see, yeah. So
Okay.
the first 2 lines are the first 2.
Yeah.
Okay.
So this one got output from the buffer. This got output in the case of object. In the case of procedure call, we also went and did the get return value of function call and procedure call, because those are extra steps that were processed. Okay? And at the other end, we converted. Here we see that the deserializer said, oh, I couldn't handle this particular piece. So you see that it's trying to deserialize this particular object. It says, sorry, I couldn't succeed. And so that's what happened here. And you see how things are getting converted back into by this deserializer here, that the buffer got converted into a serializable call, and somewhere here we went and return an RPC return value, and somewhere here we went and called the method, called this. Okay. And if you guys just give me one more minute. The message received listener that we had. Remember, it goes and checks if you got a byte buffer or if you get an object. If it's a byte buffer, it goes and decodes a byte buffer to see whether it is something can be converted into an integer, and then calls increment with that integer. Otherwise, it goes and just calls increment with that value. What does this mean? Did this particular receive listener that we put on the RPC port get the serializable call or not that arrived? We know a serializable call arrived at the server. From this code, right? Otherwise, we would go enter this particular part and we'd get into a class exception. So what's going on? Why did the receive listener not get the serializable call?
This happened after the deserialization.
Yes, after deserialization.
What comes out is either well,
So did listener receive the call? No. Remember, the listener was added to an RPC port. And we go through this particular pipeline here. And it was received in the object port. The received call invoker invoked the method and never sent the message to the higher levels. So the received listener, the RPC port, never got the message. I had a slide before where it short-circuited. It went and, so it goes and says, oh, what kind of message have I got? If I've got a serializable call, I'll go and make the call. Otherwise, I'll send the message across. Okay? So there is this filtering going on. Okay. I'll start from here next time, but you've basically got everything you need for the assignment. So one thing we did not get into last time, which is important for assignment 4, okay, and if you don't understand this, your assignment just won't work, has to do with this commented out part in the set factories. Okay, so we saw the notion of factories and how they're used, and we saw many kinds of factories, and then I started getting into what these specific factories have to do with. So we sort of got back into componentization of the RPC implementation. And we saw that we could do our own call completer and our own call invoker. And you have to do that to make sure that you can build on top of the receive statement, okay, that you guys implemented in assignment 4 in your first part. So let's talk about another one, which is the asynchronous custom duplex receive call invoker. So Sam, you used it. What has that got to do with? What does that do?
The asynchronous one?
Yeah.
I honestly didn't actually figure out exactly what it did.
But you used it?
But I used it.
And it started working?
My thought was, I guess the problem I was running into is if you use the same sync call invoker for both sides, then whenever your server called back your client to do its method that it needed to do, like process command, that was in unblocking the sync call invoker from the other side, the receive on the other side, on the client side, pretty sure.
Yeah, I don't understand. Brennan's just come right in time to answer the question. So why did we need the asynchronous call invoker?
What was happening was one client would make a call to the server, which would block that client. And the server would make the calls to the other clients, which would block. But then the calls were synchronous calls, so it would never receive a response from the clients that it sends it to, so it would block like
Okay. It would just block, okay? So the issue has to do with what I talked about a long time ago, that, you know, what thread? So there are two issues here when you talk of call invoker. One is, how do we complete the call? How do we, you know, what do we do with the, what messages do we send back? Okay, do we send back a message for procedure calls? Do we send back a message for function call? Okay, so that's one issue. How do you deal with the call? And secondly, in what thread do you deal with the call? Okay, and those two things together are done by sort of the call completer. So what happens by default is that which thread executes a remote call, Brennan?
the server or client side.
Either side.
Is it the main thread? That's why you need a
Hang on, the main thread is the one that initiates maybe a call.
'Cause it's
After that, the main thread is no longer around, okay? So when a call is received by a process,
It's
okay.
like the asynchronous response handler thread or something.
okay, that could be one thread, but that's that's one default. But by default, that's not what's invoking it. By default,
Is it
the selector thread executes it, okay? That's a default. And I've told you guys, the selector thread shouldn't do anything complicated, and yet I sort of did something wrong, okay? I made the selector thread do it. And, creating multiple threads is costly. And I figured that if your RPC calls are not doing anything complicated, they're not calling back, why not just use the selector thread? It'll be quick, okay? Plus, I wanted to show you guys a reason why the selector thread should not always be doing it, okay? So the selector thread is the one that makes the call. And what you might, and then you get into the deadlock situation, because you make a call in the server or the client, okay? And that call, let's say the server, because that's the typical case, the selector thread executes that call. Now that's making a call, and that was a call that returns a value, or
I don't think so. I think it was just because we used explicit receive, so every single send was synchronous.
okay. So if it's a synchronous call, so what happens is if it goes and calls something back, it blocks, okay? And if it blocks, and especially if it's a function call, it'll block. And if it blocks, the selector thread is blocked, it won't receive any messages, right? And in your case, it was making some call that was synchronous, right?
Yeah, like the client proxy processing.
Yeah. So that was the problem, that you're making a synchronous call. So because you're making a synchronous call, because you're making a function call, the selector thread is blocked now. So it won't receive the return value back. It's waiting for the return value, but it's the one that will get the return value of the queue also. Okay? So to handle that problem, we create another thread, and that thread is the asynchronous remote procedure call thread. That's the one you saw happening. And so that is what's happening with this asynchronous custom duplex received call a factory. It creates such an object, and that object will create a new thread, and that thread will then also, so it's the caller is responsible for both deciding what kind of message to send back and what kind of threads to create. Okay? So forwards RPC calls to separate, make some changes today. Okay, so let's try to understand how this thing is working. What it's doing is creating a predefined call invoker that takes as an argument your call invoker or any other call invoker you can give it. Okay? So you know how you can either use inheritance or delegation. So what we are doing is we are not making the call invoker a subclass of your call invoker. Your call invoker goes as an argument, goes as a delegate to this particular object, and your call invoker could go as a delegate, or the predefined call invoker could go as a delegate. Okay? So the asynchronous call invoker is a separate object that is only interested in deciding what thread to create. How the call is actually completed is done by what is passed to it in its argument. So that's the flexibility, that you can compose asynchronous call invoker with your call invoker, which decides whether to send a receive, whether to send a return message for procedure calls or not. Okay? Or my existing call invoker, which sends back no message for procedure calls. Okay? So that's what's going on here, and that's the magic you have to do. And when you write your code, that you have to go and use this guy, which creates a thread, a separate thread, and then it says, okay, I'll figure out how to complete the call really using the synchronous call invoker. Okay, so is that clear? Okay, so make sure you use the asynchronous call invoker. Okay, you use a factory like this, and you make it. The factory can be a subclass of your factory. That's okay, but the call invoker is not a subclass of your call invoker. the call invoker is delegates to your call invoker. Okay, and the super.create just says, hey, whatever my inheriting superclass factory is creating, just create that call, use that call invoker. I don't have to worry about how to create that. I'm just using its factory method and then passing it to this guy. Okay. Okay. Now that's an asynchronous custom duplex received call invoker that I provide. Okay. You could have written your own asynchronous call invoker that creates not one thread but works like RMI, creates a separate thread for each call. Okay. So that's what I want to talk about. So we could create a call invoker like that. As it turns out, how many of you have seen what the send call looks like? What are the contents of send? When you send a call, what all are sent to the remote party? Okay, so what all should be sent? The destination. So I'm making a call, I'm saying increment 5. So what all should I send? And I'm making that increment 5 on some proxy.
Right, so the
Name of the proxy, okay.
increment 5, then that message serialized into a buffer.
Okay, so somewhere I want to capture the name of the method
Yeah.
and the arguments,
Yes.
right? And this name of the method and arguments and maybe the class name also, okay? But the class name is actually, the other side knows what class it is. And that name, class, and arguments can be used through by reflection, using reflection to figure out which method to call at the other end. Anything else I should be sending? Should I send a call ID saying this is the 10th call or the 11th call and have every call have a unique ID?
Yeah, because if you make a bunch of the same calls, you know you get the return from those calls, which of the many calls it corresponds to.
So if you make multiple calls to the same server, you have to know, we know when a call comes in, which process it came from. But should we also know which call it was? Now, as it turns out, Gypsy doesn't send that. There's no caller ID sent. Call ID. So that kind of works out, or it works out under certain assumptions.
Does it have to assume they're synchronous, so you know that it'll be like full and the same outstanding, so you know when you get one back, it corresponds to the previous one?
So Gypsy does allow multiple threads on a client or on the caller to invoke calls. But in the callee, it's either the selector thread or the asynchronous thread that's dealing with it. So they will get serialized at that point. And all these calls will go through a single, so actually even that can create a little bit of a problem, because if they don't go to the central thread. So as long as the calls are invoked in the same order at the other end, and by having a single thread there, you ensure that things get ordered at least at the server end, even if they didn't get ordered in the client end. There's also a queue, a central queue at the caller end that serializes the calls. Okay? So all the threads are putting their requests into a common object, so they get serialized there. They get serialized through the thread there, so they will be the values will get returned back in the same order, in which you will take the things out of the queue. Okay? And but if I start creating multiple threads at the server end, that constraint is broken. Okay? So I thought of putting a caller ID as caller ID, and at that time I wasn't thinking of having multiple. I still don't quite think it's a good idea to create a separate thread or to have multiple threads executing calls, but there may be applications where that's important. So I'm thinking of actually adding the caller ID now, and that will require conflicts with the current call scheme, call ID not sent, cannot match calls with return values based on sequence number, based on the order in which they arrive back. Okay. So I don't say the sequence number is sent, but based on the sequence in which they return back. Okay? And this involves, right, you guys have seen, or at least those of you who finished assignment 4, you've seen how I did it, right? I had a queue, and we would just take the return value back, and you would put the return value. So that's very easy. The order in which you take, if it's the same as the order in which you put, it all works out nicely. What would I do? What would one do? Supposing I'm not using the receive calls, I'm using just my queue. How would you handle multiple calls? Let's say I send the call ID and I get back a call ID. Now how would you handle it?
Like a hash map or something.
So you would have a hash map of call IDs.
Yeah, the mesh that's stored in that group or whatever.
So yeah, that would be a way. So the hash map would get created when?
Probably when you did the send, you would put it in the map with some call ID, and then when it came back, you could pull that object out and match it with whatever the call ID.
You could then wait on that object.
Yeah.
Okay.
Because hash map doesn't hold the things in terms of keys. They need some sort of custom.
You're using the call ID as the
You'd put the call ID as the key.
Where we no longer care about the ordering,
Yeah.
because our ordering is being specified by when we actually get it.
You would be able to guarantee the order of your methods, which I guess is a different problem.
Sorry?
So, you couldn't guarantee the order of your methods. So if you said increment and then print, and your increment you just have to be handled by the server after the print, then the print might come back before the increment, in which case you could get weird behavior there.
Indeed, that's why I never liked. So if a single thread did increment and then print,
That would make sure.
then at the server end, they can conceivably be executed in different order.
Yeah.
That is why I never kind of thought of that situation, and I never liked that situation. And but we can just have factories that decide what's going to happen, and the mechanism that you're describing would still work, even if there was a single thread at the other end, right? It would still work. You just there's no reason why it wouldn't work. So that would be a more flexible mechanism. I was actually thinking of a mechanism I'm just talking, which is I wanted to show you the benefits of notify all. Can you see how with notify all this could work? Okay, so let's forget that. Now, so you guys are doing it with receives. You're not using a queue. So how would it work with your receives?
When you receive, you check the call ID to see if it's the one you expected.
Okay, so when you get the message, you receive a message, you check it, and if it's not the same one, then?
You put it into your buffer.
So now we're using buffer. We can't quite use the receive directly, right? But can you imagine a more complicated receive, kind of receive we've studied earlier that could solve the problem? A conditional receive?
And then you
No. What kind of receive is that? What is the technical term for the condition? Guard. Now you could have a guard associated with the receive that says, give me this message only if this condition holds true. Right? So I've taken a practical problem and shown you why that something like that would be useful. Okay? Okay. So the solution I was trying to give here is that, I was trying to give a solution that will isomorphic to the solution that you would use to receive. So you could have a queue, and whenever a message comes in, it could just wake everybody else that's waiting. They could check if the ID that came matches the ID they were expecting, and if so, they would take it out, else they would let it remain there. Okay, but actually I like your hash table solution better because I don't have to do any notifies. Okay, but I was trying to also show you why this notify all might be useful. Okay, and receive, we could use guarded receive. Okay, that would be the right way to do it. Or we can build some cumbersome mechanism that is both receive and and queue-oriented. Okay. Okay. Now, so I'm using this lecture to do multiple things, to show you how Gypsy works and is componentized, and also how to show how we can do customization. And one of the nice things that happens with this mechanism is that you can just make runtime calls, to change the factories. I mean, that's great. Okay, it's not working. We go and see whether it's working with the Gypsy factories. It is. Go back here and see what's going on. Okay, so we didn't have to change source code. That's beautiful. Just change the source code of the system that we're changing. Okay, we might have to change our source code to decide which factories to use, but we didn't have to have access to the Gypsy source code or change it in any way. Okay, that's great. What would be even nicer is if no code had to be changed. We didn't have to change our code, and we didn't have to change Gypsy code to change the behavior. So what would that mean? If you're not changing any code, where is the decision being made? Runtime, but how is the runtime? The runtime is looking at what? User input. Some kind of configuration file. Okay? So we could have a configuration file that the system reads, okay, and says, for duplex client input port, use this particular class as the actual class. We know that the system needs a duplex client input port. We know that the system needs a call invoker, call completer. So we use a key. As the key, we use the conceptual thing, and then we give to the key a value, which is the real class. And with Java especially, you can take this class name and actually instantiate it at runtime. Okay, so a lot of tools actually do this kind of stuff. They may not have a nice factory mechanism inside, but wherever they need a class, they will go and read this file. So there is a level of indirection, and the perfect thing is to actually have both kinds of solutions. Okay, so just wanted to point this out, that this is a very important. This makes the system really flexible.
Why would you need to outfit both of those, both the factory and the config file? What is one of them does visualize?
So why would you need both the configuration file and a factory?
Yes.
Anybody?
So you have a factory, you can actually make changes at any time in your code. So you could even you have a UI and you say, I want to use this class instead of the class I was using. You can make that change immediately, whereas at the very beginning of runtime, you can use the config file and you're stuck if there's not factories.
So
I found a lot of situations.
So programmatic versus you can always enter things through. So this is interesting, because how many of you have programmed in an interactive application on an Android, or anybody done it? So the whole UI layout is specified through a configuration file, and configuration files are good, but they may be missing. Okay, they may have syntax errors. So my viewpoint is that the application, the coder provides a set of defaults. Okay, and then if there is a configuration file around and it's got the right syntax, and the trouble, and you can see why the kind of errors you can make here. What if I go and type a wrong class name here? There's no one to check that. In fact, there was somebody who gave a talk here who's trying to build configuration file checkers. Okay, so I would not want to rely completely on configuration files. Okay, I would like to provide a whole mechanism for the programmers when they can use it, and then so there's a hierarchy of customization. There's something that Gypsy gave you. There's something that Gypsy user, the client programmer, said was the right thing for that thing, for that program. And you don't even let the users change it, because you feel in this application you really would like a single thread. Okay? And then you give a subset of the options you give to the user. And there, if you don't like the entry for the call completer there, you don't even read that entry. Okay? Plus, you don't rely on there being a configuration file being correct. Okay? But you're kind of right that if I provide this file, and if I'm a programmer, I can sort of very quickly check if the class, the class is right or not. I know how to debug the message. Then I wouldn't do this.
Yeah, I just thought it was like used internally, doesn't matter which where we go, right? It's public, so like you're doing this on public cloud, and any tenant can change their own config. In that case, you might want to separate some of the stuff they can say
Yeah.
from some of the stuff they can't say.
Yeah. So you might want to sort of separate these two things out. And the question then becomes also, where's the configuration file? Is that in the jar, or is that in the local directory? And fortunately, Java does let you find files in the jar. There's a method. There's a way to get that. So installing configuration files gets to be somewhat of an issue. Okay, yeah.
How did you say you can use like that line to use that specific class?
Because that's what I've done, right? In this line I've said, this is the conceptual, on the left-hand side is the conceptual thing. The left-hand side corresponds to a selector. The right-hand side corresponds to a class name. So it says whenever whoever needs a client input port, okay, they don't go to the factory selector and say, create this thing. They go to the configuration manager and say, give me whatever value you have for this particular key. The configuration manager goes and reads the configuration file and figures out for that key, it's got this particular class name. And it gives you back the class name, and you instantiate it, and you've got an object. And by the way, here I can't pass arguments to the classes. If you notice in Gypsy, we have to sometimes pass arguments to classes in the constructor. So this is more limited, that there is no, you might be able to have some syntax for predefined arguments, or what if one object has to be an argument of another object. Okay, so what if like we saw the asynchronous call invoker. The asynchronous call invoker took a synchronous call invoker as an argument to its constructor. Okay, so what happens when the constructor has multiple arguments? So the factory solution is more general in that way.
So when you instantiate that class, you have class argument?
Yeah, there is. You can say new instance, and when you say new instance, it expects a constructor with no arguments, and it calls that argument. That's what reflection assume. Okay. Questions? So the way I would do it, I would have factories and configuration file. So the selector would go in to see whether an entry exists. If an entry exists, it will use that. Otherwise, it looks at the programmed entry. Okay. So that to me is the perfect way to do things. Okay. But again, we all have limited time, so one could just do just configuration file. Okay. So exactly what you were saying. Or no, you don't even have abstract factories and factories. Just let the instantiator check the configuration file directly. Okay, and we can have a configuration manager that just takes a key, finds the class, instantiates the class, and returns you back an instance. Okay, so certainly, like I told you, there's a gourmet kind of food we can create, and this line, the top line says how to do the gourmet one, and the bottom one says how to do a healthy one, but still not junk food, right? Which is just instantiate class directly. So there's multiple levels of effort you can put in, and so I'm just giving you a spectrum of choices. Yeah.
So like the configuration file works even if you can't work, even if you have no factories or anything?
No, whenever you have, whoever needs it, I'm just imagining a configuration file manager that has keys and classes.
Right.
And you tell the configuration file manager, give me an instance corresponding to this key.
It just gives you a new version.
And we can even specify whether it's a singleton or not. And if it's a singleton, it will just give you the same instance again and again. So that will be another configuration thing. And this solution, by the way, I think is used in some tools. Okay. Yeah.
Just as an example of an invalid syntactic or syntactically invalid.
Is this wrong?
Let's get that.
Between customization and a custom duplex.
There's no dot?
Yeah.
See, and I make all the mistakes that any person can make. So that's why I need Java. I need type checking. So there you go. And what I did was, I copied from the package. I was trying to not make a mistake. So I copied the package. I copied the class name. So I did not make a mistake there. But I forgot to put the dot in between. Okay, I think so. Let's go and summarize. So customization is what this has been mainly about. And key idea is that you should have multiple classes implementing the same interface. And we can have static methods in the class that's instantiated. Okay, so I'm kind of calling it kind of the provider or some class that provides some service. It can also provide a static method to instantiate that class. Okay, we've seen that solution. I believe in KMP's class we use that, and that's great for creating singletons, but not a great idea for substituting classes. Okay, so then we can have factory classes, which are classes whose job is only to create other objects. They don't do anything else. Okay, so they can have create methods that return instantiate classes, return singletons. So they are separate from the provider class. And then we can have multiple factories for different kinds of objects. So somebody has to choose which factory. So I believe the technical term is abstract factory, but the abstract factory doesn't instantiate a factory. Okay, you need factory is a singleton. So it just goes and selects between factories. That's why the recursion ends. Okay, so the factory is the one that creates, selector that selects. Okay, and now we can also have, we saw that in the provider class we can have static methods that create objects. So we'll call them static factory methods. There are also instance factory methods that can be around. And the instance factory methods can be in the class that uses a class, or they can be in a factory class. Okay, so supposing I need a counter and I am a counter user. So the counter user can have a static, an instance method that says create counter. And a subclass can create a different kind of counter. Okay, so that instance method is there, it can be overridden. And then it can also be in a factory class. The counter factory can have a factory method that some subclass of that factory can override. Okay, which you guys have done in your assignment number 4. Okay, so there are all these choices, and the best choice is to have factory methods, instance factory methods in factory classes. Okay, that's the sort of gourmet gold standard here. Okay, you can also have a configuration file, and then we got also into call thread creation. That you have flexibility on what threads execute a call, but currently that interferes with the fact that call ID is not set. And your quiz asks you this question. So if I change Gypsy before you finish the quiz, assume the version of Gypsy that exists today and not the version of Gypsy that I might change it to. Okay? Questions on this?